Hey everybody, I've had a couple questions about one of the problems from the section on integration by parts, so I wanted to walk you through it. As we go along, anytime you feel like you know what to do next, please pause the video and do it yourself so that you get the most benefit out of working on this problem. Okay, so here it is. It's number 48 from section 7.1. And we're supposed to prove this formula. This is called a reduction formula because it gives you the integral of a power of cosine in terms of an integral of a lower power of cosine. So in principle, you could just use this formula over and over again with different powers of cosine to evaluate the integral of any power of cosine. Okay, so let's see what happens. Now there is an example in section 7.1 similar to this but with sine, and you can sort of use that to give you the idea of how to get started. And the idea is what we're going to do is take this integral of cosine of n, cosine to the n of x dx, write this as the integral of cosine to the n minus first of x times cosine of x dx. And writing it this way, now we can do integration by parts. U is going to be cosine to the n minus first of x, and then dv is going to be cosine x dx. If you're going to do integration by parts, you kind of have to do it this way because if dv were cosine to the n minus first of x, well, how do you integrate cosine to the n minus first of x? We don't know, so you kind of have to choose u and v this way. So this means du is, let's see, that n minus 1 comes down times cosine to the n minus first of x. And then by the chain rule, we have to multiply here by sine of x. It's easy to forget that, sine of x. Also, we get a minus sign when we differentiate cosine to get that sign, so we need a minus sign in front. And then finding v, if dv is cosine x dx, then v is just sine of x. Okay, so now we can use integration by parts to rewrite this integral, and it's going to turn into a proper mess, of course. So u times v, this is going to be cosine to the n minus first of x times sine of x minus the integral of v du, so v is sine x, times, I'm going to have to, all of the lines on this calculation are going to be long, so always I'm going to have to be splitting each step of the calculation across a line, so I apologize for that. Let's see, sine of x times, so now we'll move over here, du, which is n minus 1 times cosine to the n minus, oh, I made a mistake up here. This shouldn't be a 1 right here. This should be a 2. Okay, so n minus 2 of x times sine of x times dx, and then that minus sign in front of du, it's going to turn this minus sign from integration by parts, turn that into a plus. Okay, now let's simplify this a little bit. We get cosine to the n minus first of x times sine of x plus the integral of n minus 1 times cosine to the n minus 2 of x times, and then we have 2 copies of sine in this integral, so that's sine squared of x dx. All right. Now from here, this sine squared, anytime you see a sine or cosine squared, you should think, hey, maybe I could use a Pythagorean identity. So let's try that out. cosine to the n minus first of x times sine of x plus, while we're at it, let's pull this n minus 1 outside of this integral. So n minus 1 times the integral of cosine to the n minus 2 of x times, let me move this up a bit, times, all right, so now we're going to use the Pythagorean identity. Sine squared is 1 minus cosine squared of x dx. All right, and now when we multiply out the stuff in this integral, we get two integrals. So cosine to the n minus first of x times sine of x plus n minus 1 times, so this first integral is cosine to the n minus 2 times this 1 here, so that gives us integral cosine to the n minus 2 of x dx minus, and then the second one, we get this cosine to the n minus 2 times this cosine squared. Don't forget about the n minus 1, so n minus 1 times the integral of cosine to the n minus 2 of x times cosine squared of x. Well, when you combine those powers, you get cosine to the n of x dx. All right, and this minus sign right here, that is there because of the minus sign in front of the cosine squared. All right, so this would be a good place to stop. Actually, let me just remind us that this came from the integral of cosine to the n of x dx. So this would be a good place to stop and see if you can work the rest out yourself, because there's something nice has happened here. We have the integral we started with, integral of cosine to the n of x dx, on both sides of the equation. And that means we can solve this equation for the integral that we want, integral of cosine to the n. So if you think you can handle that, then stop, give it a try, and see how it goes. Okay, so if you're still watching, that must mean you want to see me do it. So I will oblige. Let's start by just adding to both sides of this equation the integral of n minus 1 times cosine to the n of x dx. So we're going to add that to this side too. Add n minus 1 to the integral times the integral of cosine to the n of x dx. Okay, I see that on the left I wrote this n minus 1 inside the integral, and on the right I wrote it outside the integral, but it's a constant, so it doesn't matter which place you put it. So on the left-hand side, we have this integral plus n minus 1 times the integral, and that means adding these together, you get n times the integral. So n times the integral of cosine to the n of x dx. And then on the right-hand side, of course, these n minus 1 times the integral of cosine to the n, those just cancel. And the right-hand side becomes cosine to the n minus first of x times sine of x plus n minus 1 times the integral of cosine to the n minus 2 of x dx. And then last step here, which is good because I'm almost out of room, divide both sides by n. And over here, divide by n. That has the effect of multiplying by 1 over n. And over here, divide by n. And then on the left-hand side, of course, the n's just cancel. And now we have the reduction formula you wanted. So I hope that helps. Let me know if you need any more help.